Okay, so this lecture starts with a little bit of a reminder of, we did this in lecture 1, so just to recall, so we have our number line, and if we want to write inequality x less than 2, all we do is we locate 2, and then we are going to grab a different color, and we're going to do all the numbers that are less than 2, so everything to the left of 2, and since this is a strict inequality, I'm going to put a parenthesis there. And that would denote that interval right there. Um, and there's the graph, and then it also asks us to write it as an interval. So the interval here would be from negative infinity all the way to 2. So we did this before. So for example, for part B, you just grab your real line here. Now you have to locate 2 points, -1, very straight line by the way, and then 4. And so the numbers we're interested in are going to be the numbers in between -1 and 4. That's what this inequality is telling us, is the x's, or the numbers that are going to be greater than -1, so to the right of -1, and less than 4, so to the left of -1. So it would be right here. And now this one is a strict inequality, so it's going to be open. And this one is inclusive, so it's going to have a closed interval right there. So you have then that interval, and if you then write it in interval form, you basically get the closed interval from -1 to 4 open. And then similarly, we would do the part C, which is going to be from -2 all the way out to 3. And then the numbers we're interested in are the numbers in between them. And this one is open because it has no equal sign here. This one has an equal sign, therefore I need a close. Granted, it should be right over to -2, but you get the point. So in this case would be the close interval from -2 to 3. And that's the first thing we needed to remember, because now we're going to use this knowledge to graph inequalities and solve inequalities. Firstly, linear inequalities, and then we'll get a little bit more involved. So let's stop here for a second. Okay, so here we're presented with a problem that is not quite the same as what we had before, but we can transform it the same way we did with equations. So for example, I can subtract 7 on both sides. This side gives me 2x plus 7 minus 7, so just 2x, less than 2 minus 7, -5. Then divide by 2 on both sides. Now I'm allowed to divide by positive numbers. Remember, whenever you divide by a negative number, you gotta reverse your inequality sign. Remember that. But here then I end up with x being less than -5/2. And then you can draw your inequality now the same way we did before, where we have your -5/2. Sorry, I'm writing a little bit small there. And you're looking at the numbers that are to the left of it, because you're looking at the numbers that are less than that. And it's open because you have a strict inequality. And so that interval right there, or the solution set to this inequality, will be the interval from -infinity. So where do I write it? Probably going to write it here. It's kind of bad location, but I ran out of space. From -infinity to -5/2. And I leave that interval open because it's strict inequality. So that gives me my first problem. Now for this one, we operate the same way now, except we're going to be adding or subtracting x's in order to isolate x. I tend to prefer to add, just because then I eliminate the negative signs, but it's not necessary to do that. You could subtract x on both sides if you prefer. So now since I added x, then I'm going to end up with 2x here plus 1. So let me subtract that 1 so that I end up with only numbers on one side and only the variables on the other side. So what that does is I get negative x plus x cancels, and I get negative 3 minus 1 is negative 4. That's going to be less than x plus x is going to be 2x. And then I had the 1 minus 1 that canceled. Remember, I'm dividing by a positive number, so I can do that without reversing my inequality sign. I'll try, yeah, I will have a negative 1 to divide here in a second, so you see how that works out. So here I get a negative 2 is going to be less than x. So when you try to draw that, you're going to locate your negative 2, and you're saying that you're interested in those values of x that negative 2 is less than, or in other words, x is greater than negative 2. So you're looking to values to the right of x. And again, it's an open interval because you have your strict inequality there. So that becomes your interval. And if you want to write the solution, then the solution set is simply going to be, and I'm going to have to write it here, what again, it's going to be from negative 2 to positive infinity. So you see it's a little bit different as above, just because instead of going to the left, I'm going to the right. But that's it. Now, I am not going to follow in order from the notes, because right now I would have to have problem C. But let's assume E comes right after B. And let's solve this one right here. So I'm going to subtract. So what is going to be the strategy? Let's start with that. I have an x in the middle, or a term that involves x rather. So I'm going to try to leave the x isolated there. So to do that, what I'm going to do is firstly, I'm going to subtract 1 in every part of the inequality. I can add and subtract at will. That I can do. This time I'm not going to combine all the steps just because I want you to see how it works. You can operate everything, every part of this inequality by adding the same number. In this case, negative 1. So negative 2 minus 1, negative 3. I was going to write negative 2. Then here I get 1 minus 1 cancels. I'm just left the negative 2x. And then I'm going to be less or equal than 3 minus 1, which is 2. Now, this is what I wanted to note, or why I wanted to make a point here and do it slowly, because you see I have a negative in front of my x. When I do that, I gotta be really careful. I have to reverse my inequality. So when I divide here by negative 2, I want to have negative 3 over negative 2. Now, this would be less, but remember I'm dividing by a negative, so it's going to become greater than, and then I'm going to have my negative 2x over negative 2, and then this one will be reversed as well, so greater or equal than 2 over negative 2. And at that point, then I operate here, I get 3 halves is greater than x and is greater or equal than negative 1. Now, that looks ugly because we normally don't read inequalities from right to left, if you will. Our intervals don't go from right to left, but if you rewrite it, let me continue here to the side, you will see that it will look a lot nicer. So less or equal than x, less than positive 3 halves rather. Otherwise, it would not make sense. So then you see now it does make sense. You go from negative 1. I didn't change the inequality, by the way, from here to here. I did not. I just rewrote it in the opposite order, but the inequality signs are in the same direction as they were before, meaning that x is going to be greater than negative 1, and here you'd have x greater than negative 1 if you read it like that. So I just reversed, not reversed, but I just rewrote the inequality starting with negative 1. So going from negative 1 to 3 halves. And now the negative 1 is inclusive, so if we include negative 1, and we don't include the 3 halves because there's an equality sign here, and there's not an equality sign here. So that's how we determine which one has a square bracket when it's included, when there's equality, and open, just regular parentheses whenever it is not included. So that is how you solve this type of inequality. Now, for the next one, which is f, even though I did skip C and D, we'll look at this one right here. Now, firstly, there's this component to it. And so how can this fraction, or this rational expression be positive? The only way is if x is positive. If x happens to be negative, then this is not satisfied. So this first part is basically going to give me the fact that x is positive. Why do I care? Well, because when I address this second part, I kind of would like to multiply times x, so I can put the x not in the denominator, but in the numerator. But I cannot do that and leave the inequality sign in the same order if x happens to be negative. But this part of the inequality gives me that x is positive. So at that point, I can grab this second part, and I can freely multiply times x on both sides. I know this is dangerous. You don't want to multiply times x across an inequality sign. But in this particular case, I can, just because I have the guarantee that x is going to be positive. If I didn't have that, then I don't do it. Please don't. But in this particular case, I can. So I get 3 is less than 2/5 of x. And now I can proceed as we did before. I can multiply both sides of the equation times 5. Sorry, the inequality times 5, my bad. So I'm going to multiply both sides times 5. So let's put 5 here. That's going to cancel my denominator. I'm going to get 15 is going to be less than 2x. And then I'm going to divide by 2 on both sides. Where then I obtain, so I'm going to continue to the right, that 15/2 is less than x. And so I can draw my interval, locating 15/2, always to scale, as you know. And I'm going to go then to the right because I want x to be greater than 15/2, or 15/2 to be less than x. So I just grab this part of the interval, and I write it in interval form as 15/2 to infinity. Alright, and this video is already kind of long, so I'm going to stop right here for this video. I want to continue the next part of the lecture on a separate video.